Hello, thank you for joining this session. My name is Kelvin Wee, and I'm the Technical Director for Asia Pacific and Japan at SentinelOne. Over the next few minutes, I'd like to discuss with you about the SentinelOne Endpoint Protection Platform and how we are providing our customers the capability to detect, contain, and recover in minimal time with AI and automation. I'd like to begin my presentation to talk about the threat landscape that we see today in the cyber world. Our threat researchers at Sentinel Labs constantly look at the various threat activities that's happening, and we publish articles on a very regular basis. Earlier this year in July, we highlighted that we saw the Wasted Locker ransomware. And this is partly because we saw a rise in the threat activity that's specific to this form of attack. Just within hours of our post, ZDNet reported that Garmin was one of the victims that got hit by this particular ransomware. It is important to stay ahead against this form of cyber attacks. And at SentinelOne, we provided our customers with this advantage, leveraging on predictive technology and artificial intelligence. The article that was published by ZDNet indicated that Garmin services was down. Some of their production lines were also impacted. I am a Garmin customer myself. The screenshot that you see here was taken directly from my phone. There was no connectivity to the service. And if you go to their website, this was the same message that you'll see. So one of the things to take note of is that the Wasted Locker ransomware is a relatively interesting one in the sense that it's not just a ransomware encrypting your files. When we looked and dissect this particular malware in our lab environment, we could see all the various processes that was running and the actions that it was trying to do. Beyond just the ransomware attack, there were a lot of other things that were being performed, such as evasion, application persistence, even privilege escalation and exploitation. So we were able to see that from end to end, what the attack was trying to do. And we were also able to map the behavioral of this particular attack to the MITRE ATT&CK framework from the threat indicators itself. So this was how we were able to determine and see how this particular form of attack was targeting the victims, and Garmin was one of them. What is interesting about the ransomware itself was that not only did it encrypt the files, but it also attempts to delete away the shadow copy. So for those of you who are familiar with the Microsoft Volume Shadow Copy technology, what it does is that it takes snapshots of your system files, critical files, including your documents and so on. Now, from a SentinelOne perspective, we protected our customers against this form of attack at the very early stages. But more importantly, the anti-tampering mechanism within the agent itself prevents the agent from being corrupted. And we also have protection mechanism for the Microsoft DSS so that the images or the restoration files will not be corrupted in case you get a form of attack like this. Now, when it comes to ransomware, you know that you've been compromised because your files would have been encrypted. There would have been a ransom note that you need to pay for the ransom to unlock your files. And then you will have situations whereby your desktop wallpaper might change. But some of the more advanced attacks that we've seen are like Trojans. Now, this article that was published in 2017, 3 years ago, we highlighted that we saw a new variant of the Emotet banking Trojan targeting at financial institutions. Now, specific to this one, what it does is that when it attacks the victim, it doesn't tell the victim that they have been attacked, right? So there are no clear indicators, there were no files encrypted, the wallpaper doesn't change. But what it does is that it tries to collect the credentials of the victim via the browser as well as the email passwords and so on. It pretends to be a legitimate document with very clear instructions that is protected and you have to launch the macro to view the content. So when the victim actually tries to open this document and launch the macro, nothing really appears to happen. But what has actually been done is that the credentials would have been harvested. The hackers then can use those credentials to launch a more advanced attack on the compromised system. Now, again, like you might be wondering, why am I bringing bringing a 3-year-old article up? Because we do see variants of this particular Emotet reoccurring from time to time. So last year in October, the Australia Cybersecurity Centre highlighted that they saw a spike of the Emotet attack of the malware coming as a form of a word attachment disguised as a statement or an agreement or some sort of invoice, and that has been distributed to various email addresses and so on. And that was last year. July of this year, we saw ZDNet publishing an article indicating that they saw another variant of Emotet to be coupled together with a botnet, and it returns after 5 months of absence, right? And this time around, close to 250,000 messages were being sent worldwide. And you could see in the heat map, these were all the different countries that were impacted by this form of attack. In September, France, Japan, New Zealand also issued warnings around the spike of Emotet attacks that they have seen. And more recently, in October 1, ThreatPost posted this article indicating that hundreds of US organizations received emails supposedly coming from the BNC, and it was part of a spear phishing email campaign where victims would then receive an take to action email with documents being attached to it, and that is the one that's being tainted with the Emotet attack. So I think in various discussions that I have with organizations, more and more organizations understand that conventional security does have its limitations, and they're looking at something more advanced. They're also aware that the endpoint is a critical part of their infrastructure, especially we have people now working outside of the corporate infrastructure, working from home in the current COVID pandemic situation that we are in. And so that becomes the weakest link in the organization. How do they then provide the best security or the best form of protection for their employees and users? Apart from just the protection itself, I've spoken to various CISOs as well as IT operational teams, and one of the biggest concerns they also have would be the incident response part of their day-to-day operations. The concept of time to contain, the amount of time that's needed to contain a machine when an incident happens, right? So what you do when an endpoint is under attack or has been compromised, the kind of effort, the time and effort that is involved when it comes to that sort of attack. Now, when I do this level of discussion with various organizations, a lot of them come back to me and say that the first priority that they have in terms of time to contain is to isolate or to disconnect the machine. How are they doing it can be a very manual process. They may not have sophisticated tools to do it, but the whole fact around how they perform this particular action becomes a very, very tedious task. Point number 2 is an interesting one because organizations who are still leveraging on signature-based type of solutions will try to get signature update and try to perform a scan on those machines just to try to mitigate that. Now, the reason why I use the word try is because in many of these form of attacks, it might be a form of a 0-day and the signature base may not be updated. And you might have to manually update those hashes, and the scanning process can also take a very, very huge toll on the resources. Points 3 and 4 relates to the IT operational team because they would then have to handle the incident. And in many cases, if let's say the system has been corrupted, then they will have to restore the last known backup or a factory image of the system itself. I'm beginning to see a lot of organizations who are more interested in understanding the attack vectors, the root cause analysis, the forensics part of it, to see the full cycle of the attack and trying to understand what the method has been used when they have been compromised. So one of the challenges in this aspect is that you need to have necessary tools and the platform to help you get all these details. And if some of these tools are not available during the course of the attack, and you do not have a good way of monitoring all these different processes, then it's very hard to reconstruct some of these information that you see and information that's needed to understand the form of the attack itself. I'm going to spend the next few minutes to talk a little bit about the Sentinel-1 autonomous endpoint protection with the active endpoint detection and response. We are a platform, a single agent that is installed on the endpoint to provide a wide scope of security layers to prevent, to protect, and even to provide the remediation when an attack actually occurs. The first layer of defense that we have is the real-time file analysis, which is our static AI file models. This gives us the capability to analyze a file when it comes into the system. So think of this like an X-ray machine. We'll be able to look at the different attributes of the file and very quickly determine at machine speed whether this is a malicious file or whether this is a legitimate file. Now, how we are able to do that is because our mathematical models have the capability, and we have been training these models for more than 6 years. So there's a certain level of maturity in doing a very quick determination about what is true and what is false, right? What is malicious and what is not. So that would be the real-time file analysis that gives the first layer of defense at a pre-execution stage. Now, when you have the situation like the Emotet banking Trojan, where you have macros that are being hidden within the document files itself, what is going to be interesting is that when that executes, when things happens in flight, the attack actually happens in flight, being constructed and so on, having the ability to understand all the processes and all the functions that's happening at the endpoint, it will be very key from a endpoint detection and response perspective. So this is the part where we do the code analysis, and we'll then be able to identify which are the malicious behavior that's happening on the system itself. The legitimate applications that are running, the benign actions, those will still continue to run, but we'll then be able to identify the malicious processes and then take the necessary remediation action automatically or manually, and that can be configured within the policy itself. So we could perform things like kill quarantine. We could even do a one-click remediation, as well as a one-click rollback, or even to isolate the machine from this aspect. So those are all the various capabilities. With the deep visibility component, this is where we are able to then look at the details around the root cause analysis, the different artifacts, and the different cause of attack that actually occurs. So the next segment of my presentation is really to provide you with a very short demonstration about how we are protecting our customers against the various forms of advanced attacks that you see. In the environment that I have here, I've got two virtual machines that are being set up. The first machine that I'm going to introduce you to is my malware zoo. I call this a zoo mainly because this contains all the different viruses and malware artifacts that I've got. This does not have any security products that's installed here, and so I keep all this intact. What I'll then do is that I'll launch an attack on a system that's protected by Sentinel-1, and then I'll demonstrate to you how we are able to do that detection, containment, as well as the recovery for our customers when you get this form of advanced attack like the Emotet one. Okay, so to my demonstration, the first machine that I'm going to introduce you to is my malware zoo. The article that you see over here, this is the Emotet attack of 2017. If you do visit our website, and specifically to this particular blog that we published, we indicate the details about the threat, what our threat research team has done. There's even a video about the attack and how we protected our customers from it. What is also interesting is that you'll see a sample IOC or indicator of compromise. And if you were to look at this particular hash value or the signature base value, you could actually copy this and check this against a reputation website like VirusTotal, for example. So if I were to go to VirusTotal and if I try to search for this particular hash value, you will then see it gives you a track record about all the vendors that are able to detect this particular threat and which are the ones that could not. So you could see that there are about 43 out of 60 who are able to provide some level of protection against this form of attack. So in my environment over here, I do have that actual artifact that was mentioned by my threat research team. If I were to look at the signature of this particular file, you'll notice that this is the identical signature that has been indicated over here. So just to do a very quick validation, I'll pop this across, and you can see that this is the 43 vendors that is able to pick this up. The disclaimer I'm going to mention here is that I am dealing with live malware. This has already been validated over here. You can see that this has been recognized by the community as a malicious code. I'd like you to think with me now, imagine with me that if I was the original hacker who have developed this particular attack, this specific attack, and if I were to check against a reputation website like this, I would see that 43 vendors would have been able to pick this up. Now, if I know that most of these vendors are using a signature-based type of solution, what do I need to do to bypass signature-based solution would be to do a mutation of this particular file. So let me prepare the environment. I'm going to use myself as a victim, right? I'm going to copy this file across into this folder. And let me just rename this file to something that the victim will most likely want to open. Let me call this invoice November 2020, right? Now, one of the things that you notice is that doing a rename of the file do not change the timestamp at all. So there's no modification that's really done on the file itself if you just do a rename. One of the techniques that's commonly used to do a file mutation is that you could use a command, a very simple command called echo, for example. And echo allows me, echo is actually a DOS command that allows me to add random numbers and characters after the file. And by doing this particular action, you notice that the date timestamp would have changed. And I could then look at the properties of this file, and you can see that the hash value or the signature of this file would have been changed significantly. Now, if I were to go back to VirusTotal and validate this particular signature, you will then see that there will be no matches found, mainly because this has never been seen before. This is a file that has been just created. It would be effectively a zero-day Emotet attack. So let me now move to the machine that's protected by SentinelOne. And this is the environment that I've got over here. You'll notice that I do have a folder that's open on the desktop. And if you recall, I mentioned to you in my network diagram that I'm connected through the shared drive, through a network share, so that I'll be able to access the different artifacts from the other machine, which is my malware zoo. So I'm just going specifically to the samples, and then you'll be able to see the Emotet folder, and this is the location in which I have prepared this file. Now, I don't care how this file got into the system here. In this particular case, I've just copied it through a file share. It could come from an email. It could be downloaded from the web. Two things I want to prove to you, right? The mutation that I've done will still make this particular package still execute because the modification of the file is really just done after the end of file. When the victim sees this, he will open this file thinking that it is a invoice document. So you notice here on the screen is identical to the screenshots that was shown by the article that was published by Sentinel Labs. When we are looking at this particular artifact now, one of the things that you might notice is that I'm not able to copy and paste this particular set of texts because this is really an image. But the victim thinking that they want to see the content will follow the instructions and enable editing. And what's going to happen is that this particular credential stealing action will be performed. Now, I want you to notice here is that not only did we kill the process and quarantine the file, this particular connectivity that I have on my machine has now been contained. And this is done automatically. So I've set the most aggressive policy that I've got here to do an automatic containment, just to illustrate to you that the automatic containment is possible from a SentinelOne perspective. And this is something that can be configured at the policy level. What will be interesting would be to see the actual threat that has actually occurred. This is the dashboard that you'll see. If I drill down into the incident itself, you'll notice that this is the invoice November 2020 document that was open and has been contained. You can see that that has been mitigated. More importantly, if I look at this particular endpoint here, you will notice that the network status is disconnected because we have contained the machine, right? But the console connectivity still remains online, meaning that as the administrator of the SentinelOne solution, I will still be able to investigate and perform all the various mitigation actions and remediation on this particular machine while it's still being contained. So the unique part about the agent is that when we talk about containment, it will block all network traffic, it will block all communication to everything else except for its communication to the management console. And this gives me the opportunity to understand this particular attack, where it originated from. You can see that the originating process was Explorer because I've copied this through the Windows Explorer itself. And it tells me that this is a document script kind of attack that was detected by our behavioral engine and is classified as a malware because there's all these different obfuscation, evasion techniques that's also being used. So this is a very classic case in which how we can detect the behavior of a particular attack and determine that this was malicious because of the MITRE ATT&CK framework. Going into the details of the forensics itself, I will then be able to see all the various processes that have occurred from the time when Winward opened the document down to this particular one, which will be of interest is because this is a obfuscated PowerShell command that was launched as a byproduct of the macros within the Windows Microsoft Word itself, right? So it was at this point that when we detected this and we killed the process and we also killed the parent process as well. And this is how we protect our customers against this specific variant of the Emotet attack. Now for the IT administrators or the IT operational team, what will be of interest would be to see the detailed report about what has actually happened. One of the things that you notice here is that there are a lot of events that have occurred, and specifically around the files related event, you can see that there are several file creation, modification, and so on. I'd like to draw your attention to this particular one. This is a file that was written specifically into the app data local temp folder. Now, one of the things I like to highlight is that we have seen a lot of attacks that occurs, right? Some of the more advanced attacks. And what they like to do is that they would like to put artifacts or indicators within the app data local temp folder is because this is one of the hidden folders by default in the Windows environment. Now, from a behavioral engine perspective, a Word document creating temp files would be considered as a legitimate action, as a authorized action, and nothing malicious about it. But when we detected that it was trying to do a credential stealing, that's where we will stop it. Now, knowing this fact that files like this have been created, then what would be the next course of action that you will take? Security best practice then tells us that we should remove some of these residual files and some of these indicators because this could be used as a form of a next wave attack if there are indicators like this. So just to give you a proof of point, if I were to go to this machine now, I go into the C drive, and remember I told you that it's in the users, and app data would be a hidden folder by default. I have actually unchecked the hidden folder part, going to the app data local, and it was in the temp folder itself. And you'll then notice that this particular file that was created here, this one, this is the one that was created as part of the Emotet attack. So I'd like you to take note of this. is F curly bracket FBA, and this is that specific file that was created as part of the Emotet attack, right? Now, one of the capabilities that we have is to remediate. I mentioned to you about the one-click remediation. Remediate allows us to delete all the files and system changes that was created by this threat. If I were to click on this and click on apply, and let me move over very quickly over here, what's going to happen is that the agent will then be given instructions to go back in time and undo the damage that's been done. So one of the things you'll notice over here is that that particular file that was created, which we detected, now gets removed because we have done the remediation action. One of the things that you notice over here is that you'll see that the remediation status has been activated, and there were 340 thread creations that were successfully remediated. Now, if I were to click on the CSV report, then this will give me the details about the specific remediation actions that were done. And you can see that there were files that were being restored, that was being removed, registry keys that were being modified, and that also has been removed. A total of 340 actions that were taken as part of the remediation action itself. Now, as the administrator, now that I'm happy that the system has been cleaned up, has been properly remediated, I can then choose to reconnect this back to the network. And with this action, you'll notice that all this is through the click of a mouse will then be able to restore the network connectivity. Once the agent receives the restoration command, it will then restore the network connectivity to the device itself. I've come to the end of my presentation and demonstration. Thank you for your attention. Take care and stay safe.